Hello guys, welcome back to my YouTube channel. I am Mayur, studying in Sri Venkateswara College of Engineering. We're gonna learn vector space, the building blocks of modern applications. We're gonna learn introduction, what are vector space, application in physics, applications in computer graphics, applications in data science, applications in machine learning, vector space operations, eigenvalues and eigenvectors, conclusion. Introduction. Today we'll explore this fantastic topic and dividing into too many applications in field such as physics, computer graphics, data science and machine learning. At its core, a vector space is a simple a collection of objects that can be added together and multiplied by number or scalar. However, the properties of characteristics of these spaces can vary gently depending on their dimension, basics and other factors. So bulk up and get ready to explore exacting word in vector space. What are vector space? A vector space is a collection of vectors that can be added together and multiplied by scalars. The idea of a vector space is one of the most fundamental concepts in mathematics, with applications in many different fields, including physics, engineering, computer science, and data analysis. Vector space provide a way to describe and analyze mathematical objects that have both magnitude and direction. By representing these objects as a vector in a vector space, we can perform operations on them, such as addition and scalar multiplication, which allow us to manipulate and analyze the meaningful ways. For example, in physics, vector spaces are used to describe the force acting on the object and its motion through space. In computer graphics, vector spaces are used to create 3D models and animation. And in data analysis and machine learning, vector spaces are used to represent and data analyze in large set of data. Applications in physics. Vector space play a crucial role in the study of physics, particularly in the analysis of force, motion, and energy. By representing physical quantities as vectors, physicists can use vector space operations such as addition and scalar multiplication to manipulate these quantities and gain insights into the behavior of physical systems. Consider the concept of work, which is defined as the product of force and displacement. By representing force and displacement as vectors, we can use vector manipulation multiplication to calculate the work done on an object by a given force. This approach allows us to analyze complex systems involving multiple forces and direction, providing a powerful tools for understanding the physical world around us. Applications in computer graphics. Vector space play a role in computer graphics, partially in the collection of 3D models and animations. In this field, vector space are used to represent the position, orientation, and scalar of object in scene. By multiplicating these vectors, designers can create complex shapes and movements that bring their creations to life. Image a 3D model of a car. Each point of the car surface can be represented as a vector in three-dimensional space. By applying transformations such as translation, rotation, and scaling to these vectors, Designers can create the illusion of movement of depth. This is how computer graphics software is able to render a realistic looking scene that simulate the behavior of light and shadow. Applications in data science. One of the most exciting applications of vector space is in the field of data science. In this field, vector space are used to represent and analyze complex data sets. By representing data as a vector, it becomes easier to perform operations such as clustering and classification. For example, imagine a data set consisting of a customer information for an online retailer. Each customer can be represented as a vector, with each dimension corresponding to a different attribute such as ages, gender, or purchase history. By analyzing these vector, the retailer can gain insights into the customer behavior and performance. Another important application of vector space in data science is in natural language processing. By representing words on a sentence as vectors, it becomes possible to perform operations such as semantic analysis and text classification. For example, imagine a dataset consisting of a customer review for a product. By representing each reviews as a vector with each dimension corresponding to different words or page, it becomes possible to identify patterns and trends in data. This can be useful for improving data, product designing, and marketing strategies. Applications in machine learning. Vector space plays a main role in machine learning, providing a powerful mathematical framework for creating algorithms and models. By representing data as vectors in high-dimensional space, machine learning algorithms can identify patterns and relations that would be difficult or impossible to detect using other methods. One important application of vector space in machine learning is in the creation of classification models. By mapping input data to a high-dimensional vector space, this model can separate different classes of data using hyperplanes or other geometric structures. This allows them to classify new data points based on their position relevant to these structures. Other applications of vector space in machine learning include clustering, dimensional reduction, and features selection. Vector space operation. Vector space are mathematical structures that allow us to perform various operations on vectors. These three main operations that can be performed on vector space are addition, scalar, multiplication, and linear transformation. Addition involves adding two vectors together to create a new vector. Scalar multiplication involves multiplying a vector by a scalar to create a new vector. Linear transformation involves transforming a vector in some way, such as rotating or scaling it. Eigenvalues and eigenvectors. Eigenvalues and eigenvectors are important concepts in the study of vector space. In simple terms, an eigenvector is a vector that, when multiplied by a matrix, result is in a scalar multiple of itself. The scalar multiple is known as eigenvalue. This may seem like a complex idea, but it has many practical applications in field such as physical and engineering. One example of eigenvalues and eigenvectors are used in the study of mechanical vibration. In this case, the eigenvectors represent the different ways in which an object can vibrate, while the eigenvalues represent the frequencies at the which these vibrations occurs. By understanding eigenvalue vectors and eigenvalues of the system, engineers can design the structure of machines that are less likely to fail due to excess of vibration. In conclusion, we have explored the fantastic world of vector space and their applications in various fields. We started by defining what is vector space are and why they are important in mathematics and other areas such as physics, computer graphics, data science, machine learning, and etc. We have delivered into specific example of how vector space are used in these fields, including the study of forces of motion in plane, the creation of 3D models and animations in computer graphics, and developments of algorithms and models in machine learning, and the correction of encryption algorithm. We also discussed important concepts such as basic and dimension eigenvalues and eigenvectors and various operations that can be performed on vector space. And so understanding vector space is a crucial for anyone instead interested in this field, and it opens up a world of possibilities for exploring and innovations. We encourage you to continue learning about this fantastic topic and explore its applications in your own work and research. Thank you.